What's up, everybody? This is Matt Taylor here. I want to start a YouTube channel, and amidst of all the chaos of the coronavirus, I teach 5th grade math and science at Southwest Orange Elementary School, and I'll be kind of hosting a variety of conferences and meetings with my students along the way, but I want to share some lessons with all of you among 5th grade parents or 5th grade students who want to attend. These will be fully online. It's a YouTube channel. It's Mr. Taylor's Classroom. But we'll be hitting all kinds of 5th grade math standards, almost covering all bases in 5th grade. So if your kids have missed anything throughout the year at this point, if they just tune into this channel, they'll get all they need. So first and foremost, I want to start with some geometry. But before I do want to highlight my kids that are watching. So welcome to my former babies. We'll get this together as a community. It takes a village to raise our kids, and that's why I'm here. I'm hoping I can reach out to more than just our area, but to the whole state of Georgia as well. So if you're watching this, appreciate you tuning in. Like I said, this is for parents and kids alike. I know parents look at the new math standards as, I didn't learn that way, so how can I teach my kids? Well, the good news is in math, there's only one right answer. And so if you just teach your kids a certain way, they can rock and roll whatever way you teach them, as long as they have it in life. That's our main goal. So as long as you bear with me, I'm going to teach you a new way as well as the old way sometimes. So if you just watch this channel, you'll get an introduction to a lot of new things as well as a review of the old. So I'm old school, but I'm going to teach the new ways that our kids learn today as well. So you'll get kind of both sides of the story. Now, like I said, I'm going to start with geometry today. Geometry, we're talking about the hierarchy of quadrilaterals. That's a big component in 5th grade geometry. So when we look at the quadrilateral hierarchy, we have quadrilaterals at the top. Now, I've kind of drawn a hierarchy for you, if you will. A big conception that I tell my kids at school is a square is a rectangle, but a rectangle is not a square. And it's kind of mind-blowing if you think about it, but at the same time, it's really kind of based on their attributes. Attributes, a vocabulary word that we hit on a lot in school. If you hear attributes, you also hear the word congruent in 5th grade a lot. Both those I'll hit on in just a moment. But I want to talk about the hierarchy for a little while. My students had an assignment in Google Classroom. They were actually watching a video on geometry and polygons. Now, polygons, a quadrilateral is underneath the umbrella of a polygon. Now, a polygon in general is actually referred to as a regular polygon, or it could be an irregular polygon. Now, my students know, and you'll see in a moment, I'm no artist by any means, but an irregular polygon is basically something like this. All right, you're going to have a few different sections, a few different lines. All the lines are not congruent, or they're not equal. Congruent means equal. So instead of saying the word equal, we're going to use the word congruent in today's lesson. So if you look at this polygon here, it's irregular, meaning it is uncongruent. It means all these sides are not the same. Now, I do have a regular polygon here at the bottom that's a square. Now, you will see that I have little dashes that represent where, and you can zoom on the video if you will, but it's actually where the video itself, when you zoom in, you'll see these lines. These lines mean that these lines are congruent, which means they're equal. So a square has 4 equal sides or 4 congruent sides. That's an attribute of a square that makes it different than all other quadrilaterals. And we'll address that in just a second, except for the rhombus. And so what I'm referring to is when we talk about a regular polygon versus irregular, a regular, all sides are congruent, whereas an irregular, all the sides are not congruent. So now we've covered that basis. Many of you are asking, what is a polygon? Well, if I drew you a picture here, all right, all you see is an angle. All right, but an angle is not classified as a polygon. You see, because when you look at a polygon, all the sides, it has at least 3 sides. A 3-sided polygon, as well as you know, will be a rectangle. But having just 2 sides, I'm looking at just an angle. I can't have a true polygon unless I close this shape in and have a 3-sided figure. A circle, all right, for example, has no sides. Therefore, a polygon only refers to those that have 3 sides or greater. Now, as I continue on to look at quadrilaterals, so tomorrow we're going to focus on trapezoids, and more specifically, backtrack a little bit, like I said, it's normal classroom. So not trapezoids, but triangles. So today is quadrilaterals, tomorrow will be triangles. But with quadrilaterals, you really have it broken into 6 major areas. All right, so we have here the trapezoid first. The trapezoid rule recently changed. So it used to be it had to have just 1 pair of parallel sides. Now we have changed, the Council of Mathematics changed it to having at least 1 pair. So at least 1 pair, not just 1 pair, but at least 1 pair. So the trapezoid actually used to be sitting over here on the hierarchy, but now it has actually moved where it's located now, which is here in the middle. Now when you look at the hierarchy itself, the trapezoid is moved just below quadrilaterals, and it has at least 1 pair. So again, at least 1 pair of parallel sides. But as you go down, you'll see a parallelogram. A parallelogram is a little bit different in that other than a trapezoid, parallelogram actually has 2 pair of parallel sides, not just 1. And the difference between a parallelogram and the rest of these, all these are types of parallelograms. So I'm going to stop for a second and go back up. So again, a trapezoid, at least one pair of parallel sides. A parallelogram has at least two pair. So at the most two pair. It has to have two pair of parallel sides. When I'm looking at these two, I see these two are the same and these two are the same. Again, when you hear someone say same, make sure and stick in the word congruent. Congruent, again, is a synonym for same and equal. That's a vocabulary word we're going to use very frequently. So congruent is what we're hitting on. So a parallelogram has two pair of congruent sides. However, it also has two pair of parallel sides. Now, a parallelogram is broken down farther into a rhombus, a square, and a rectangle. All right. Now, we'll start with a rhombus. A rhombus has four congruent sides. All right. Many students, when I say that, they instantly think of a square, but that's not the case. All right, because a rhombus does not have any right angles at all. So a rhombus actually is more specifically known. Some people refer to it as a diamond sometimes. Some have it incorrectly. But think about a baseball field. So the baseball diamond itself is actually would be considered a square if you turn it correctly because it has four right angles. So it's not necessarily a baseball diamond, it's actually a baseball square just turned at a different angle. So when you look at a rhombus actually has four congruent sides. With these four congruent sides, again, there are no right angles, and that's why it's in a classification all on its own. Now, as I go across to the rectangle, a rectangle does have four right angles. But what makes it different from a square is that a rectangle has two pair of congruent sides. Not all sides are congruent. So you see these two are congruent and these two are congruent. And if you look at these squares represent right angles. Now, going back to fourth grade standard, in Georgia, a right angle measures 90 degrees. Now 90 degrees, that can be added up to be 360 degrees for all quadrilaterals. So for example, if I have four angles in every quadrilateral, because quadrilateral has four sides, quad four. So if I have four sides and I add up all four angles, they'll give me 360 degrees total. All right, so if I add up these four 90-degree angles, 4 times 90 is 360. So again, I focus on rectangle, we hit a rhombus, now moving down to a square. Now a square you see has four congruent sides and all the congruent angles, which are 90 degrees. So a square, that's what makes it different than all the other quadrilaterals, is that it has four congruent sides and four congruent angles. It also has 360 degrees, all right, but it also has the capability of moving up the quadrilaterals to the hierarchy. What I mean by that is, in the hierarchy, I have arrows that are pointing down. So as the arrows point down, that means that you can only move down in a hierarchy, all right? So rephrase that. So when you think about a hierarchy, you think about normally the top is like the king or queen of a kingdom, or the president of the United States, and there's people under the president, or a principal of a school, there are people under the principal, all right? So you look at this is kind of like the beginning, but you don't really think about what's beneath it, all right? But quadrilaterals is broken into a lot of different areas that are very important. Square, all right, the bottom is the most important. So I wore this shirt for a reason. It says, be the revolution, and it's kind of Ron Clark Academy in Atlanta, but revolution, Ron Clark once said that revolutions start from the bottom up. So in this, the square is the bottom, and it actually will go up. So when I break these down, these arrows actually are reversed. What I mean by that is a square can actually be a rhombus. A square can also be a rectangle, okay? If I look at rectangle, a rectangle can actually is a parallelogram, all right? A rectangle can also be called a trapezoid, and it could also be called a quadrilateral. Now, going back over to the rhombus, I have to reverse the rhombus as well. A rhombus is actually a parallelogram, and a trapezoid, and a quadrilateral. Now, in these arrows, as I reverse them, you see in a hierarchy, the bottom actually has the most power, okay? A square can be any of these, and is any of these. But none of these and here can ever be a square. All right, the reason why is a rectangle can never be a square because a rectangle does not have all four congruent sides. All right, a rhombus cannot be a square because it does not have four right angles. All right, then a parallelogram, you don't really know which parallelogram you're talking about because the parallelogram refers to all three of these. So you really have to think about the attributes of each of these. Again, attribute is a characteristic of each quadrilateral. So I'm moving back up here to quadrilaterals. You've noticed the kite that I haven't talked about yet. So the kite is kind of like that person that's kind of stood off to the side, bless their heart. They don't have any friends. They're kind of off by themselves because the kite has nothing in common with any of these except for the fact that it is a four-sided polygon, which makes it a quadrilateral. Now, when I said nothing in common, the reason why, if you notice, all of these are different than the kite. Now the kite, normally, you can tell my drawing is not up to par, if you will, but a kite is a little bit different in that all the angles are a little bit different than the angles that you would see in the normal polygons. All right, so normal quadrilaterals. So the kite's off to the side. That's the only quadrilateral that is not listed in the actual hierarchy. Okay? Now if you notice again, the sides are different as well because these two sides, like in a normal parallelogram, the normal parallelogram has two pair of parallel sides. Well, if you notice, these aren't necessarily parallel, they're more intersecting and they're different lengths. So a kite has different attributes, making it away from the normal quadrilateral hierarchy. Okay? So again, it's a quadrilateral because it has four sides, but it does not match the attributes of the other polygons and quadrilaterals on this hierarchy. Now, as you look at the hierarchy and you have any more questions, you can drop a comment up under the video. I'll be glad to answer them for you. This is just a quick review of quadrilaterals to look at. A square is a rectangle, but a rectangle can never be a square. And people wonder why. And this should answer that question as to why. So I'm going to review the kind of flow chart again, if you will. So for starting at the square, again, a square can be any of these. A square is any of these. But none of these quadrilaterals can be a square because of the attributes. All right, so if you just focus on the attributes alone, which are the characteristics of each quadrilateral, you have to know that a square at the bottom has four equal sides, which is congruent. Remember that word. All right, four congruent sides and four congruent angles, and all sides add up to be 360 degrees. Well, all these add up to be 360 degrees, yes, even the kite. But the difference is, remember, a rhombus does not have four right angles, but it has four congruent sides. All right, the rectangle has four right angles, but does not have four congruent sides. Have two sets of congruent sides. A parallelogram has two sets of congruent sides, but no right angles. All right, it could, all right, but it has to be a square. All right, then a trapezoid, as you see, can only have one or no pair of congruent sides. This is actually an isosceles trapezoid, okay, which goes back up to quadrilaterals. Now, I've got the kite over here, again, bless its heart, all by itself. Now, referring to the trapezoid, all right, I said the word isosceles. Tomorrow we're going to hit on a lot of triangles and classifying those as well. With isosceles, acute, we've got all kinds of scaling, we've got anywhere from equilateral, we've got all kinds of trapezoids and tracking. See, again, 5th grade math lesson. Let me slow down a little bit. So a triangle itself, if you think about it, is different than a quadrilateral because a triangle has three sides. So there's a whole different way to classify triangles versus quadrilaterals, and we're going to look at that way tomorrow. Now, that concludes our lesson for today. I just, again, want to hit the hierarchy of quadrilaterals. I'm doing this for my students just to get a 5-minute overview of the skills they're practicing at home. Now, again, like I said, this is for them. The main reason I basically transformed, this is my shop at my personal home. I've transformed it into a mobile classroom, if you will. I'll be doing several experiments, several hands-on things along the way to kind of, sometimes maybe an opening, sometimes maybe a closing, to kind of spark their interest as well. But the main goal of this, again, is to, hopefully offer help to those that need it. Again, this is a 5th grade math overview. I will hit some 5th grade science as well. I have a garden at home. I'll be looking at doing some gardening as well, some videos of that. So make sure you keep tuning in to see what's upcoming next. I do want to show you something before we go. I do have a little trick. It's called flash paper. Me and my students have seen me use it in class. But tomorrow's night's lesson and tomorrow's day's lesson, we'll actually talk about why this happens and what this is made of. Now, this is not normal paper. There is something different about this. And we talk about chemical and physical changes in our science lessons, and this is what it's referring to. Now, so as this burns, you can see there's no smoke, there's no ash. You wonder what's going on. Well, if I go, it disappears. And you wonder, why does it disappear? So tomorrow night and tomorrow, we're going to talk about why that disappeared and what chemical change took place. Now, so that concludes our lesson for tonight. Again, geometry, hierarchy of quadrilaterals. Remember, irregular, regular polygons. And tomorrow, we'll really get into more polygons as we talk about classifying triangles. Thank y'all. Hope y'all have a